computing in final FC layer, we need to do return prediction and by using like loss function. So after computing the meaning of losses, so you can create the optimize CNN model and to get the Adam optimizer, creating a trainer to train CNN model. So, so to create final FC layer, you will get the code of hybrid it and create fully connected layer and compute dot product plus bias. In this, like you need to return and optimize and trainer. By using these all, you will get in trainer the optimizer, minimizer, cross intermediate mean. Now we need to create like phase 2 train and test CNN model on cipher 10 dataset, creating a variable initializer to initialize all the variables, setting steps like x minist train with 5000 images. Each time of training, run the whole process with one step. Like each time of training, use one batch of inputs. Like in one batch equal to 50 images. With this total number of batches is 50,000 by 50 equal to 1000 batches. Steps 5000. Finish the training after running 5000 times. Running TF section to train and test deep learning CNN model. In this phase 2, we have created a variable initializer by using steps of train with 5000 images. Each time of training is equal to one step. In one step, we have used a batch of inputs and each batch size equal to 50 images. By running this, we can use like to train and test deep learning CNN model. So after train and test CNN model, you can get the code by accuracy of prediction classification is moderate about 68.52%. Initial accuracy was at 13% in step 0 and it increases gradually from 38% at step 100 to 56.42%. At step 1000 and 64.96. At step 2000 it shows like 65.43 and at step 3000 shows like 61 At step 4000 it finally shows 68.52. This means 68% of times the clarification are true. So you can see in code it's like showing like steps equal to 5000. With the use of 5000 steps we can create this code. So now you came to part 4, conventional neural network performing. From the comparison of accuracy results from MNSID dataset and CIFAR10 dataset, we can see that initially at step O, both of the networks had an accuracy percentage of 13%, but later the MNSID dataset has trained very well, resulting in almost 98% accuracy. On the other hand, CIFAR10 dataset has shown gradual increase and stabilized at 68% at the end of 5000 steps. There can be many reasons for such variations. When coming to the later, it is 3 into 32 into 32 layer image with higher resolution compared to 1 into 28 into 28 size input image for MNSIT. Hence, the better training of the model is required. So now we can to part 5. In part 5, you need to improve convolutional neural network performance. Suggest improvement technology would be learning rate optimization, starting with the base LR and subsequently decreasing it for the next epoch. Increase the model capacity, increasing model depth and width, greater number of layers and number of filter in each convolution layer, and batch size should be like usually try with max batch size, increasing image resolution from 32 into 32 into 3 to 64 into 64 into 3 are a higher size. Random image rotation, like changing orientation of the image. Fine turning the model with subset data. Dropping a few data samples of the overly samples data classes. Fine tuning the model with the subset data. Dropping a few data set of the overly sampled data classes. Fine tuning the model with trained data. Use the model to predict to train data. Retain the model for the wrongly predicted images. In part 5, like we need to improve conventional neural network performance. Like to improve conventional neural performance, there is no significant